So I'm going to be talking about the various levels of monkey patch hell. So my name is Kyle D'Oliveira. I work at Clio. We provided you pizza and beer. Woo! So before I jump in, just a question. Does anyone not know what monkey patching is? Okay, we got a couple. So I'll give a quick explanation as well. So monkey patching basically is being able to reopen classes and add or change or modify behavior. And so you can, with Ruby, you can kind of do anything and no one can really stop you. So we're at VanRuby. Ruby is great. But actually one of the really big reasons why Ruby is great and where it is because of monkey patching. It's actually a pretty powerful tool that lets us do a lot of stuff with the language. If you're kind of new to Rails and you start interacting with things, you may have seen stuff like this, where you can actually specify things like, hey, I want something 5 days from now. And it's very readable. And there's a lot of convenience here, and you can read things, and you understand exactly what's going on. If you look at the top example where we're just modifying like a time object, well, we've got some numbers. I'm guessing that probably works out to 5 days, but I would have to go in and double check. Not entirely sure. Is this a millisecond thing? Maybe this would be wrong. But I can, if I see 5 days from now and that code's been tested, I know this is 5 days from now. So it actually adds a lot of readability and helps for one of Ruby's biggest strengths, which is developer velocity. Ruby kind of sucks a little bit on the performance side compared to languages like C, but we can read it, we can move fast, and that's one of the big advantages of Rails in the startup world. It actually lets us also like reopen classes to fix some broken shit. Even with like the actual core classes, what I can do is I could reopen a class, for instance, like net HTTP, and say, hey, whenever we initialize this, I actually, if you didn't set a timeout, I want to set a timeout on when you open, so that if for some reason the connection hangs, it'll time out after 60 seconds. Without this, it'll just kind of hang indefinitely. There's some, the alias method chains are not really important. Basically, they just help wrap behavior. There's arguments whether or not that's a good thing to do or a bad thing to do. It's just a way that we're doing it for the purposes of this talk. But it also lets us add convenience too. We've got new classes, things like big decimal come about. You have to kind of pass it as like an argument. Well, it'd be really nice if you could just convert an argument like with 2i, 2s, and you could just say, hey, I got this string that's, I know that it's a float or a decimal, and I just want to convert it to a big decimal. I don't want to do anything like that. I don't want to like create a new class and pass it as an instance and assign it back to a variable. I just want to call a convenience method on it. It kind of helps for readability, makes us move faster. There was actually an interview with Mats, who is the creator of Ruby, and he actually talked about how the monkey patching ability is actually kind of what made Rails what it is today with DHH's help. And although there's some things that we're doing now that's not monkey patching, a lot of it actually kind of stemmed from the very beginning. But the downside is Ruby is awful because of monkey patching. It is a super powerful tool to let you do whatever you want, but it's a super powerful tool that will let you do whatever you want. And you can really cause havoc if you're not careful with it. One of the big things here is that it's pretty much unstoppable. There's nothing that can really stop you from monkey patching someone else's code. Last year, or I think the year before that, my company decided to have like a Ruby tank game where somebody actually just went in and monkey patched everyone else's tank so that he would win. And it doesn't really matter what you do. There's a gem called Ruby Refrigerator that tries to freeze classes so that you can't monkey patch them, except for that you can monkey patch them if you want. So you can't really stop people from doing stupid shit. And it's kind of a double-edged sword. Monkey patching is really easy to get the behavior you want right now, and it is a nightmare to maintain. And that's really where the problem comes down. Getting the code working right now is easy. It's a useful tool for debugging, useful tool to kind of see what's going on, kind of you can reopen classes, put logging, put debuggers, but if you actually have new behavior that's introduced through monkey patching, it's really difficult to start understanding, particularly if you're not familiar with this. And it's hard to detect. I just grabbed random stock images, so there's my random stock images for the rest of the day. And here's a story about where things go wrong. So we'll look at pagination. pagination is a problem that I think everyone needs to see, unless you're dealing with a toy app that literally wants to load everything into memory all at once, which if you do that, you're wrong. You'll need to paginate your data somehow. And there's a couple gems that will do this. One's called will paginate, one's called Kaminari. There's probably a few others. You could do it locally because it's not actually that difficult. You don't need an entire library for it. But basically what ends up happening in this scenario, the code's not really super important here. There's a gem, it's called will paginate. It reaches into the active record relation class and adds a method called page. The actual content's not super relevant, but method is called page. Kaminari does something a little bit similar, except for you can't read it because it does something funky. But surprisingly, the default is page. So if you combine both Kaminari and will paginate in the same project, they override each other, and depending on the order that they are loaded, you will get different bugs. So you actually could even, like, if you order them dynamically, you can get different bugs with the same production code base. All of a sudden, one's going one way, one's going the other way. And you may think, well, you're paginating, just pick one library, stick with that library, you're good. Well, has everyone heard of a gem called Rails admin? So it's a little tool, helps people do that. There's actually a dependency in Rails admin on Kaminari. So if you use will paginate and you decided, hey, Rails admin, pretty cool, let's include it, you'll get this bug because it brings in Kaminari as a dependency and you just monkey patched your own stuff. So this is the dangers of monkey patch. If you're not careful, you can ruin people's day. And I mean, this was an issue for a while that kind of just floated around. Lots of people ran into it. I mean, this is not costing you, but it's costing other developers time because someone made a gem that monkey patched this stuff and wasn't careful about what they decided to call it. So monkey patching is about trying to avoid it when you can, and if you can't, understanding the risks. So we'll start a little bit with a very simple way to avoid stuff, but then we'll actually dive into monkey patching and understanding the risks involved with it. So the first tactic to avoid monkey patching is typically just decorating and extending. And we're going to go through like a contrived example that actually existed in the code base of Clio. And basically, there's this gem called page object that's really useful for integration tests, help us to pull forms out so we can fill them in for the purpose of Capybara or Selenium. But one of the big things that it wants is a class level method that determines what the field is, and we need to give it a CSS or an XPath selector. And sometimes those need to be dynamic. We have here that we have like a CSS selector with an ID of note_1, assuming that's the first note. But if it's a second note, this won't find it. Third note, no good. We need it to be somewhat dynamic. And I mean, we could do brute force, reopen the proc class, give it like a 2s method that just delegates off to call, and then we can hand it a proc. And this will work. I will actually now end up with a dynamic string that I can do pretty much anything I want with. But this is one of the tools where, as like a developer who learns about monkey patching and all the power, it is the hammer and everything is a nail, which you need to take a step back and understand when this is not. And this is just really easy. You could, for instance, just make a simple decorator. It's a simple, plain old Ruby class. You give it a proc. You can have the 2s method. You just call it, and it works. You just now have a proc string. And this is much safer. I now know the extent of the damage that this code will add, which will be only this code. If I monkey patch proc to add 2s, who knows what damage I could cause? Maybe someone else is relying on the fact that they want to print procs to the console. I don't know why you want to do that. Or maybe to a log, and all of a sudden it starts getting executed again. But decorating is just one method to do things. You could easily have just made a subclass of proc that calls this method, does the same thing, and it still works. And if you're running into an issue with a gem that you need to monkey patch to fix, you can actually like fork the gem, fix the gem locally, or in your repository, and use that version. And if you're a good Samaritan, submit a pull request to fix that bug. But if you can't get away from monkey patching, then you've entered robot hell. And this is where the code lives in hell. Developers are fine because you can go home, you can go away, but the code is not in a happy place. So, first level of monkey patch hell is adding new behavior. It's kind of the limbo of hell. And this is, we've seen, like, I've already talked about this, we're just adding like convenience. I know this method doesn't exist on string right now, I can add it, it doesn't cause any problems. But the problems really start to arise in the future. What happens on a Ruby upgrade? What happens if they implement 2BD? Is their method better than mine? What if they actually wrote it in C and it's faster? What if someone actually wrote it and it does something slightly different that's better? Well, we'll just monkey patch over it and we'll lose that behavior. We also lose a little bit of assumptions about the language. You start working with a language, for instance, if you're familiar with Rails, which I think most of us are, have you ever gone to like a non-Rails project, just a Ruby thing, and started using things that active support added, like present, and wondering why the fuck does this not actually work, right? So it changes the assumptions of what we have about the language. So it's got some good and bad there. But if we need to go further, this comes to level 2, hell, where we're wrapping existing behavior. So things start getting a little bit darker. And there's actually a lot of benefit that we can have from wrapping existing behavior. Here's actually an example. Again, code's not super important because I'll describe what it's doing. This is actually an example that we use from Clio. It's a little bit simplified. But we reopen the MySQL2 adapter in the active record connection adapters classes. We're going to wrap the transaction method with the alias method chain. Again, there's a lot of ways you could do this wrapping behavior, but basically we want to put something around it and then call the original with pretty much little to no changes. But what this will actually let us do is monitor how long it takes for transactions to run using active support notifications. For instance, if we start seeing 5-minute transactions for something, we can actually get alerted from the developer side rather than waiting on ops to page us. And we can actually implement some testing around this. You know, if we start seeing on production that transactions are slowly increasing in time, we can actually try to look back and see where that started. But this is a talk about hell, and there's a little tiny demon in this one. And this one's worse than the adding new behavior, because we actually know that this method exists beforehand, and we're going to change it. But if we're not careful, we can end up with something like this. And you may look at this and say, what's the difference here? I'm reopening the active record relation class. I've got a method called find with relation. I'm kind of monkey patching this with the alias method chain again. I'm doing something. What that something is irrelevant because it doesn't actually do anything. I call the original, pass the same arguments. But this is really weird. If you actually load up this code in production or even in development, you every now and then start dropping conditions from your where clauses. So the best case is you may have a user of your site that's seeing something they didn't really want to see. But worst case is you're letting them see something that they shouldn't see. And that's really bad. But this isn't going to raise an exception. This is just going to silently allow it because you've reopened the class and punched it enough to say, hey, I'll do this thing, and it will just do this. And the only difference here is that the actual method definition has an implicit block. And if you don't pass that block through, you're just going to drop the conditions. So this is where the danger starts coming in, is you may actually end up with monkey patches that look sane. There's nothing seemingly wrong with it. But unless you go in and look at the original code and actually understand what it's doing and even know that the arguments match, but it doesn't have an implicit block and there's somewhere a yield, you're going to end up with problems. But let's go deeper. Let's go to the next level of hell. Let's change some behavior. This is where things start getting really dark, right? This is where you can do really stupid shit, where you can reopen the string class, and whenever someone wants uppercase, just give it to them backwards. And you may think about it and be like, why would you do this? Like, is there a really good reason why you would reopen classes to change the behavior? And there actually is a really good reason for this. How many people have done a Rails upgrade? A few. How many people think it's zero work? Yeah, awesome. So when security vulnerabilities come about, again, codes here is not super important. When security vulnerabilities are put, there's often patches that come about and like, here's how to fix it. You can upgrade Rails to, I guess in this case was 4.2.7.1 and get the security vulnerability. Awesome. But what if you're on 4.1? Now you need to do a full minor upgrade to get there. This is a security vulnerability. It cannot wait. So you can just dump this in right as it stands and be free of your security vulnerability. That's actually really powerful. It gives us a lot of velocity to say, hey, we got an emergency, we have a security vulnerability, let's fix it, and let's work on the Rails upgrade later, and we could just remove this once we hit the version that it was released on. So there's actually a really powerful reason why this is kind of allowed. and why there's actually good practice around it. But you can easily shoot yourself in the foot if you're not careful. But let's go deeper. Next level of monkey patch hell. And this actually may seem like a good idea, and this is where things start getting really kind of nasty. You may have, there's methods like sum on an array, and if you go into like a plain Ruby console, call .sum, you'll get an undefined method. You can actually take the variable and define a method on it, which will give you a method specifically on that instance of that object that you can do stuff on. You can call array sum, and now it works. And I've seen gems that do this. And this, you may think this is actually a kind of neat way of monkey patching, because you can limit the scope of what you're affecting. You can only affect the code that, you know, this variable is involved with. But this variable will somehow leak, and you will end up with consuming a code that is being consumed that will assume that it's an integer, but for some reason it acts like a string. And they will have no idea why, and it's because of this dynamic inline monkey patching. And it becomes quite painful to really debug this. It's really easy to write this. It took me like 10 seconds to write the array sum method. But if you're not familiar with this, and if this was like a weird esoteric method that I added, it's not in the docs. You can't find any references online, and yet it's failing on your production code, and you don't know. So you have to like hunt it down and search for it. If you search for, you know, like def, the name, you actually may not find it because there's a little thing in the middle, the array dot. So just no, don't do this. There's actually one way of doing monkey patching that is, as far as I can tell, completely unstoppable. You can't do that, and that's, you can't get around it. And this is this method called set trace func. Has anyone heard of this one? We've got maybe 5. So set trace func is the darkest level of monkey patch hell. And I'll give you an example of this. This is actually where you can monkey patch stuff without ever reopening the class, because you kind of intercept the calls and mess with them. So you can do this with C calls, but for the sake of this talk, we'll just talk about like a Ruby call. So let's pretend I've got this div method on fixed num that just does division. If I divide 4 by 3, integer division, I should get 1. That's how integer division works. Everyone expects that. But here's how we can mess with this. So set trace func is a method on the kernel. Takes 6 parameters. You can look up what the documentation of these 6 parameters are. But in part of them, one of them is a class, one of them is a method, and one of them is an event. So if I see that you are calling div on a fixed num class, I can do some behavior. And inside this behavior, I can reach in and grab all of the local variables, find their names, and produce a hash. That's basically the name that you've given it. So in this case, you would have a hash of other and the value that it actually was passed in. And then you can actually go over that array and mess with them. So you can go over all of them, and if I find any parameters that are numbers, let's just change them. Now they're floats. Now you have integer division that's not integer division. So this is why this is the deepest level of monkey patch hell. If you would see anyone do this, either fire them or quit, because you don't want to be working around anything that actually tries to monkey patch in this fashion. I'm sure there's useful things that you can do with set trace func, maybe finding like production coverage, but you should never be monkey patching with it. But if you ever need to cheat at a Ruby game, that's the easiest way to cheat, because no one will even know that you're doing it, and there's nothing they can do to stop it. But part of this is we actually want to keep code out of hell. Hell is the place where code goes and no one wants to touch it. You all have that section of your production code base that no one wants to touch. It's the thing that if you hire an intern, you just give it to the intern because they're going to be leaving anyways. So you just need to adopt some best practices to try to keep your code in good health while you are monkey patching. And one of the best things to do is actually just add comments to the monkey patch. Like, it's a monkey patch. Like, lines of code are simple. You want them to be like as clear as possible. So one of the things that we've actually started doing at Clio, and the people at Clio, you can also go into all the monkey patches, start finding them. Not all of them have them. But we actually take the original method that was written, and if we need to monkey patch things, we actually just paste the method in and then comment it out. So you can actually see what it looked like and what has changed. And then there's actual text that says, this is what I have changed. So if you do a gem upgrade at some point in time, and the code looks exactly the same, you're probably okay. If you do a gem upgrade and that section of code looks vastly different, then you know you need to dive in and understand it and potentially make a fix specifically for this monkey patch or remove it entirely. One of the other things that people don't realize that they can do is they can add tests around stuff that's not behavior. Right? We've all written the unit tests that are like, I'm going to do addition, I have these two numbers, here's what I expect the output. But you can actually do tests about your code itself. So you could actually write tests that says, I expect my Bugsnag version to be 2.5. And if it upgrades, it will fail. But you can give reasons why it's failing. You can give them the line of code in your monkey patch that says, this is why this test is failing. Go look at the new gem, go look at this place and tell me if things have changed. If it's the same and it works, update this test. And it actually lets anyone who's upgrading gems know immediately when there's monkey patches in the way. So this actually is a really useful tactic to try to do stuff. For the Rails security upgrades, if you put them in and you know that it's going to be fixed in a future version, just say, hey, as long as this version is less than the version that's fixed by, this is fine. As soon as it's more, make this test fail. And have instructions that say, if this test fails, we're obviously on a greater version of Ruby, remove this monkey patch, remove this test, then you're good. Right? You can use tests to change assert things about your code. If you forked a gem or monkey patching a gem to fix a bug, be a good citizen. Submit a pull request back to the original gem with that fix and use comments about what the pull request is. If you see that pull request has been merged, then you know that you don't need to monkey patch anymore. You're fixed, you're good. And when you're looking at gems, when you are putting any gem into your project that you've never seen before, look through it. I don't know how many times I've seen people that are just like, oh, here's a package that does exactly what I want it to do. I'll just include it. That's it. We're just going to go. But we actually want to look at the dependencies of that. What is being included in here? Actually go through the source code. Don't need to do like a code review of this, but is it monkey patching anything that it shouldn't? There's actually an interesting example that came from one of my colleagues that he wanted to use a statistics library for doing statistical analysis within Clio. Turns out the statistics library is amazing, except for that it monkey patches floats to behave like, or integers to behave like floats always. So in production, it's absolutely useless. But you wouldn't actually know that unless you kind of dug in, because it would do the statistic things and the things you're testing for exactly. It would do it right. But then there's this weird thing off to the on left field that would just fail, because all of a sudden 4 divided by 3 is no longer 1. And you were relying on that integer division. And this gem just decided that that behavior is not okay. Right? So look through the gems, look through the dependencies, look through the actual source code and understand all that. And hopefully with all that, you can keep yourself out of monkey patch hell. Thank you. Any questions?
Hello? Okay.
Hello.
So this is just more of a comment. If you're using alias method chain in Ruby 2 or plus, I think you just deserve where you are because you should be using that. This was only relevant Ruby below 2. I don't know exactly the technical details how it actually works, but the way you can actually overwrite, basically what you're really doing, you're overwriting methods, right?
Yeah, you're overriding methods and keeping references to the old methods, really all it's...
Exactly. So in Ruby 2, actually the references to the old methods still stay there. So effectively you can override a class completely in that method, do whatever the heck you want within that method and call super. So effectively that will pass it through to the original thing that you overwritten. So
I think that's the case some of the time, but not all of the time. There are cases...
It's pretty much all of the time. You really have to take a look. Alias method chain is gone effectively. Like I'm kind of surprised.
Oh, yeah, it's not a great tactic. It's just a simple tactic
It's very awful tactic because sometimes when something blows up, the exception trace effectively does not tell you what exactly happened, and you can spend days figuring out what the heck happened.
Yeah.
So you really should be avoiding that. One thing that actually helps, this is something that people normally don't use, but all the methods are set up in hierarchy, right? So when you're calling something like a method on the object, Ruby has to figure out like where exactly that method lives, and is it lives in this exact file in a superclass, or maybe it was composed somehow and was brought through the module, right? So when you call, there's a method called method chain actually, and it will actually give you an array of things where it's going to go and look for it. So it's kind of helpful. So like when you're actually calling a thing, you can actually figure out who the hell's patching it, perhaps.
Yep.
Useful knowledge.
Any other questions? All right. All right. Thank you. And go mingle. Enjoy the beer.